Is it linear and is it proportional? So in order to be linear, we're looking for a constant rate on a table, or we're looking for a line on a graph. If it's proportional, we're going to look for those same things, plus it has to have 0, 0. So it has to be linear first before it can be proportional. So this one here, I can already tell there's 0, 0. So that might be proportional. And you can see actually it's the exact same numbers. So you're adding 10 for every 10, which means it has a constant rate of 1. So that one's definitely both, linear and proportional. This one here also has 0, 0. And we can tell it's going down by 2 in the y's every time it goes up by 4 in the x's. So the constant rate would be negative 1/2 and proportional as well. Let's try a different one. Let's mix it up a bit. Let's try this graph. So this graph is a line, so it's linear, but it does not go through 0, so not proportional, because no 0, 0. This one is not a line, it is a curve, so this is not linear or proportional. This one, again, not a line, it's curving, it's a U shape, so that's neither one. This one I see is 0, 0. And I see, let's see, we're going down by 4 in the y values as the x's go up by 8. So another negative 1/2 for the rate of change, proportional as well. This one starts at 0, 2, so not proportional. And then the rate looks like it's a minus 2 over 4. So once again, it's at negative 1/2. Kind of interesting. Let's see, this one is a line. It does not go through 0, 0, so that one would be linear, not proportional. This one looks like we're going through 0, 2, so not proportional. And then it's changing from 2 to 8, it's changing by 6. And then if that's from 0 to 1, it goes up by 1, so it's 6 for every 1 for the first jump, but then it jumps a lot more. Then it goes up by 24 over the next one, so it's not a constant rate and also not proportional, so neither. Let's see, this one, we can't tell the y-intercept, so we have to work backwards if we know it's linear. So this one, 8 to 14 to 20, we're adding 6 every time. So that's got a constant rate as we go up by 10. So 6 over 10, or 3/5 would be the rate. If we work backwards, it would be at 2. So that not proportional, but linear. This one, again, not going to be linear or proportional. This one is a line that goes through 0, so this one would be both. Constant rate of 6 and proportional through 0, 0. Not proportional, not a line. Proportional going down, so linear and proportional there, going down. Again, we already kind of saw that one. Let's look at this table. So we got 3, 6. Again, we don't have the y-intercept given to us. Let's see if we can figure out the rate. So this is going down by 7. It looks like that's a constant down by 7 for every 3. So if we work backwards, we go up by 7 and work backwards, it'd be negative 4. So that's going to be linear, negative 7/3 rate, but no 0, 0, so not proportional. This one's linear and proportional. This one has 0, 1. And we can tell it's going down by 2 for every 4. So again, that's a negative 1/2. And that one's not proportional because there's no 0, 0. So we can tell basically from a table or a graph. Again, if we go back here, it's linear if it has a constant rate. And that's the y change divided by the x change. You can't just look at one of them. You gotta look at those two together, the changes. And then on a graph, it's a line. And proportional means it's a line if it goes through 0, 0. Then it's proportional.